Looking up at the stars and planets arrayed in the night sky, have you ever wondered how it's all put together? How our universe, our galaxy, our planet, ourselves, formed out of the chaos of the Big Bang? Scientists around the world have long wondered the same thing. With powerful telescopes, they've peered at the outer reaches of our universe and gradually assembled a picture of the earliest moments of its history. But many mysteries remain.
With the help of hundreds of scientists from many nations, we've assembled a powerful new scientific machine that will help unveil some of the mysteries of the early universe. This machine is not like a telescope looking outward toward the vastness of space. It's more like a microscope looking inward at the minute universe contained within the protons and neutrons that make up most of matter.
Scientists call this new and powerful microscope the relativistic heavy ion collider. Fortunately, they've also given it a friendly nickname, RHIC. RHIC is big, 2 underground rings, each nearly 2.5 miles around. That's why it took 10 years and an international effort led by the U.S. Department of Energy to build it. To understand exactly what this new atomic microscope will do, let's start with its name, word by word. First, there's relativistic, a word Albert Einstein used to describe things that travel at nearly the speed of light. Nothing can move faster than light at 186,000 miles per second. Near this speed, according to Einstein, most energy used to accelerate an object goes not to increase its speed, but its mass. So RHIC particles move about as fast as anything can go, and they have tremendous mass energy from being accelerated within the big rings. Next, there's the phrase heavy ion. Ions are atoms whose electrons have been stripped away. That leaves only the tiny nucleus made of protons and neutrons. Many machines similar to RHIC accelerate single protons, which are nuclei of the lightest element, hydrogen. But RHIC can accelerate much heavier ions up to the weight of gold, 197 times heavier than hydrogen. Lastly, there's the word collider. RHIC will bring together those speeding heavy ions in microscopic head-on collisions. The ions form a thinned-out stream of gas in bunches circulating in opposite directions inside the RHIC rings, one ring for clockwise bunches and one for counterclockwise. At up to 6 points around the ring, the bunches are directed toward each other so collisions can occur. It all happens very fast, so thousands of collisions can take place each second. This animation shows representative single ions within the bunches. The ions appear flattened by another relativistic effect predicted by Einstein. It is in these collisions that scientists will look for properties of the early universe. For a brief moment, all the protons and neutrons in the colliding gold ions, plus all the mass energy they gained from acceleration, will be concentrated into a hot, dense blob. This miniature fiery ball mimics the entire universe just after its explosive birth in the Big Bang.
The gold ions start here in the tandem Van de Graaff accelerator. It's a linear device that uses static electricity to send the gold ions on their way in the direction I'm walking. They go into a beam transfer line that takes them to the booster accelerator where they're whirled up to speed and then injected into the AGS, or alternating gradient synchrotron.
RHIC itself only provides the last big kick to its speeding ions.
Physicists and engineers from around the world have teamed up to corral these showers of particles in 4 giant detector arrays, like huge digital cameras. Each experiment can trace the many particles produced by a RHIC collision and make sense of them all.
These experiments are located around the ring at points where the bunches of ions cross, and each has a different way to look for different properties of the tiny fireballs produced by collisions, complementing one another in the quest to find new knowledge. All of them use advanced detection technology and powerful computers to reconstruct events that occurred immediately after the instant of collision. Hundreds of people worked for nearly a decade to design and build these detector arrays. Here you see one of them in a film made of pictures taken once each minute during assembly. More than 400 physicists and engineers worked on each of the teams that built the two largest detectors, STAR and Phoenix. The teams for the two smaller detectors, Brahms and Phobos, each have dozens of members. Even as the 4 experiments took shape, others took care of all the technical infrastructure that makes RHIC collisions possible. Builders, welders, electricians, and other skilled craftsmen constructed RHIC's rings with the high precision needed for the task. What will be revealed as the data come in is anyone's guess. So little is known, it's difficult even to speculate what we may find out. And that's what makes it so exciting.